So this question here, we have a helicopter that is carrying a bucket, and we've probably all seen images of this on the news. It's carrying a bucket that it drops down into a lake and picks up water, and it flies ahead. And the key thing that we are told about is that it's constant speed. So what constant speed tells us is acceleration is 0, and the F net is 0, because F net equals ma. The acceleration, if it's constant speed, the acceleration is 0, and that means the net force must be 0. And so the rope makes a fixed angle with the horizontal. So what that means is, as it's traveling, as the bucket is traveling, this angle stays the same. So which is the correct free body diagram of the forces acting on the bucket? All right, so we can see then there are 4 choices. What we have to be careful with diagrams like these are optical illusions. And what happens is things appear different or the same that aren't. And our best defense is don't trust our eyes. Measure. And you might say, well, I don't have a ruler. Well, one doesn't need a ruler to be able to make comparative measurements. One could take a piece of paper and line it up along the edge like this and mark it off. And you can move that paper and compare the lengths of things to see whether they are in fact equal or not equal. Okay, so what we have here, because they're at angles, we need to take a look at the components of those vectors. So if we look at choice A, and B, and C, and D, we can see that there are all these forces that are trying to be the force of gravity, the weight of the bucket. And there is definitely this tension on the cable. So we see that occurring. Now the question about in the first one is whether or not we might want to ask ourselves is, are these two equal to each other? Is the force at the angle equal to the one on the that heads downward, the gravity? And it turns out they are, in fact, equal to each other. If we draw the components of this vector now, it becomes a little bit easier to see that these two are not equal and opposite to each other, which means that this would accelerate downward. We're told it's constant speed and the angle stays the same. So this can't possibly be true because this one says it will accelerate downward. In the second case, if we draw the components, we see that these two are equal and opposite. And we'll just leave it at the dealing with the horizontal this time. And the second one, or the third one, excuse me, we can see that these two are equal and opposite. And the last one, we can see that they're equal and opposite. But it's this first case, we can see that they're not equal and opposite. So what we have then, and going back to choice B, is that A and the two vertical ones cancel each other out, sum to 0. And we have then a resultant force that is acting to the right. That resultant force is acting to the right. And when we look at choice C, what we have is a force acting to the right and a force acting to the left, which is this one. And so we have a net force equal to 0. In the D case, we have the vertical forces canceling each other, and this force, the last one, gets added to this like this, making a resultant of this. All we can see now is this doesn't seem to agree with the geometry or anything that's going on, so choice D definitely comes out. And what we have in choice B is a net force to the right, which means there must be acceleration. And in choice C, what we see is the vertical forces cancel and the horizontal forces cancel. And what would those horizontal forces be? This would be the horizontal tension, and the one on to the left would be air resistance, or the drag. And so that's why the best answer is choice Z. Since the net force is 0, that means there is no acceleration. Whereas choice B, which might seem like it's the best choice, would produce a net acceleration, but we are told all around that it is a constant speed. And that's why it's choice C.